Circular economy, the key to true sustainability. Course content. Introduction to the circular economy. Principles of the circular economy. Historical evolution and global context. Linear versus circular models. Design for circularity. Business models in the circular economy. Circular economy and innovation. Policy and regulation for circular economy. Circular economy in practice. The future of circular economy. Part 1. Introduction to the circular economy. What is the circular economy? The circular economy is an economic system that aims to eliminate waste and keep resources in use for as long as possible. It represents a systemic shift away from the traditional linear model of take, make, dispose, towards a more regenerative approach in which products, materials and resources are reused, repaired, refurbished and recycled. In this model, economic growth is decoupled from resource consumption. Rather than relying on the extraction of finite raw materials, the circular economy seeks to create closed-loop systems where materials flow continuously in a productive cycle. It is both an economic and environmental response to the challenges posed by resource scarcity, climate change and unsustainable consumption patterns. Why is the circular economy important? The linear economy has dominated industrial development for over a century, contributing significantly to economic growth and improved living standards. However, it has also led to unsustainable patterns of resource use, environmental degradation, and high levels of waste. The impacts are profound. Depletion of natural resources. Finite raw materials such as minerals, fossil fuels, and rare earth elements are being consumed at an unsustainable rate. Environmental pollution. Waste, especially plastic and electronic waste, is polluting ecosystems and harming biodiversity. Climate change. The extraction, production, and disposal of goods contribute significantly to greenhouse gas emissions. The circular economy offers an alternative that aligns economic activity with environmental sustainability, encouraging innovation, efficiency, and resilience. It supports Sustainable Development Goals (SDGs) and offers a pathway toward a low-carbon, resource-efficient future. Key characteristics of a circular economy. A circular economy is built on three main principles. Design out waste and pollution. Products are designed to minimize waste, pollution, and environmental harm from the start. Keep products and materials in use. This involves extending the life of products through reuse, repair, remanufacturing, and recycling. Regenerate natural systems. The circular economy goes beyond sustainability by seeking to restore and enhance the environment, for example, through regenerative agriculture or renewable energy. Global relevance and momentum. Governments, businesses, and communities around the world are increasingly recognizing the benefits of circularity. Countries such as the Netherlands, Finland, and China have developed national circular economy strategies. Large corporations are rethinking their product designs and business models to align with circular principles. International organizations like the Ellen MacArthur Foundation and the World Economic Forum have played pivotal roles in shaping the global circular economy agenda. Circular economy and sustainability. The circular economy is closely linked with the broader concept of sustainability. It offers a practical framework to achieve many of the UN's Sustainable Development Goals, including responsible consumption and production 12 Sudanese pounds, climate action 13 Sudanese pounds, clean water and sanitation 6 Sudanese pounds, decent work and economic growth 8 Sudanese pounds. By promoting more efficient use of resources, reducing environmental impacts, and creating new economic opportunities, the circular economy supports sustainable development on multiple fronts. Part summary. The circular economy is more than just a trend, It is a transformative approach that redefines growth in the 21st century. It addresses some of the most pressing global challenges by rethinking the way we design, use, and dispose of resources. As this course progresses, we will explore how the circular economy works in practice, the technologies and policies driving it, and the opportunities it presents for creating a sustainable future. Part 2: Principles of the Circular Economy. Introduction. At the heart of the circular economy lies a set of core principles that guide how materials, products, and systems should function to ensure sustainability, resilience, and long-term value creation. These principles help transition from the traditional linear economy to one that thrives on regenerative design and systemic thinking. Principle 1: Design out waste and pollution. One of the foundational principles of the circular economy is eliminating waste and pollution through thoughtful design. This means preventing waste before it is created, rather than managing it afterward. Designing products and processes that minimize the use of harmful substances. Considering environmental impact at every stage of a product's life cycle. For example, using biodegradable materials in packaging, or designing electronic devices that are easier to disassemble and recycle. Principle 2: Keep products and materials in use. This principle emphasizes the importance of maintaining the value of products, components, and materials in the economy for as long as possible. Key strategies include reuse, extending the life of products by using them again without significant modification. Repair and refurbishment, fixing and restoring products to working condition. Remanufacturing, rebuilding products to original specifications using a combination of reused, repaired, and new parts. Recycling, processing materials to make new products, reducing the need for virgin resources. Circular business models like product as a service, e.g., leasing instead of selling, are based on this principle, as they incentivize durability and maintenance. Principle 3: Regenerate natural systems. Unlike traditional models that merely aim to minimize harm, the circular economy seeks to actively improve natural systems. This includes returning valuable nutrients to the soil through composting and regenerative agriculture. Promoting biodiversity through sustainable land use and habitat restoration. Leveraging renewable energy to reduce dependence on fossil fuels. This regenerative approach helps ecosystems recover and thrive, making them more resilient to environmental stressor. Systems thinking and circularity. A circular economy cannot be built through isolated actions. Systems thinking is essential to understanding how components interact within the broader ecosystem. This means considering the entire value chain and life cycle of products. Identifying feedback loops and unintended consequences. Collaborating across sectors and disciplines to create interconnected, resilient systems. For instance, food waste from households can be used to produce biogas or organic fertilizer, closing loops between different industries. The butterfly diagram. The butterfly diagram, popularized by the Ellen MacArthur Foundation, visually represents the circular economy's two main cycles. The biological cycle includes processes that return materials safely to the biosphere, e.g., composting and aerobic digestion. The technical cycle involves maintaining the value of man-made products and materials, e.g., reuse, repair, remanufacturing, recycling. The diagram illustrates how value can be preserved and regenerated through different recovery strategies, helping stakeholders visualize the flow of resources. Value creation in a circular economy. Circularity is not only an environmental imperative, it also creates significant economic and social value. Reduced costs through resource efficiency and waste minimization. Job creation in repair, recycling, and remanufacturing sectors. innovation in product design, business models, and supply chains, improved resilience to resource shocks and regulatory changes. By embracing circular principles, businesses and governments can unlock long-term competitive advantages while addressing global sustainability goals. Part summary. The circular economy is underpinned by three key principles: designing out waste and pollution, keeping materials in use, and regenerating natural systems. These principles are supported by systems thinking, biological and technical cycles, and a focus on value preservation. Understanding these foundational ideas is essential for implementing effective circular strategies in policy, business, and everyday life. Part 3. Historical evolution and global context. Introduction. The circular economy might seem like a modern innovation, but its roots stretch deep into history. Understanding how circular principles evolved over time, and how they gained global traction, offers valuable insight into why this model is both timely and essential today. Historical practices of circularity. Before the rise of industrialization, circular practices were embedded in traditional societies. Pre-industrial economies often reused and repurposed goods out of necessity. Artisans repaired tools, farmers composted organic waste, and communities bartered second-hand items. In agrarian societies, natural cycles governed resource use. What was taken from the earth was returned through composting and organic waste recycling. The phrase "waste not, want not" summarized a mindset of resourcefulness and frugality that defined earlier generations. Although not formalized as an economic system, these practices reflected many of the principles embraced by the modern circular economy. The linear economy and industrialization. The Industrial Revolution, 18th–19th centuries, marked a major shift from circular thinking to linear production models. Fueled by access to abundant natural resources and cheap energy, economies began to prioritize mass production, short product life cycles, resource extraction, and disposability. This approach, while revolutionary in terms of growth, led to increasing resource consumption and environmental degradation. The focus was on efficiency and scale, with little regard for waste or regeneration. The rise of environmental awareness. In the mid-20th century, the negative impacts of linear industrial growth began to attract attention. Rachel Carson's Silent Spring, 1962, raised awareness about pollution and ecological damage. The Club of Rome's Limits to Growth, 1972, report warned of the dangers of unchecked consumption. The Brundtland Report, 1987, introduced the concept of sustainable development, emphasizing the need to balance economic, social, and environmental goals. These milestones laid the groundwork for a shift in thinking from linear to more sustainable models. Foundations of the modern circular economy. The circular economy emerged as a cohesive concept in the late 20th and early 21st centuries, shaped by several influential schools of thought. Cradle to Cradle, Braungart and McDonough, proposed designing products with biological and technical nutrient cycles in mind, enabling perpetual reuse. Industrial ecology views industrial systems as part of the broader ecosystem, promoting closed-loop systems and material flow analysis. Performance economy, Walter Stahel, emphasized product life extension and the value of services over ownership. Biomimicry encourages solutions modeled on nature's regenerative processes. The blue economy, Gunter Pauli, promotes innovations that are environmentally and economically sustainable, inspired by nature. These frameworks converged to form the foundation of the modern circular economy, emphasizing restorative, regenerative, and systems-based approaches. Global adoption and policy momentum. In recent decades, governments and institutions have embraced circular economy strategies to address climate change, resource scarcity, and economic resilience. European Union, The EU launched its Circular Economy Action Plan in 2015, updated in 2020, to transform production and consumption across the bloc. China introduced circular economy principles into national law in 2009, using them as a strategy for pollution control and industrial efficiency. Netherlands and Finland have national strategies aiming to become fully circular economies by 2050. United Nations and SDGs. The circular economy supports the achievement of multiple sustainable development goals, such as responsible consumption, clean water, and climate action. Circular economy in the Global South. In many developing countries, informal sectors have long engaged in circular practices, collecting, reusing, and recycling materials. These grassroots models demonstrate circularity in action, often driven by necessity rather than regulation. However, the potential for scaling and formalizing these practices remains significant. Informal recycling systems in countries like India, Nigeria, and Brazil provide crucial services but lack adequate support, recognition, and infrastructure. Efforts are growing to integrate informal workers into formal circular economy frameworks through policy reforms and inclusive planning. The role of global organizations. Several international organizations have played key roles in mainstreaming the circular economy. Ellen MacArthur Foundation, a leading advocate for circular economy adoption among businesses, governments, and educators worldwide. World Economic Forum (WEF) promotes public-private partnerships to accelerate circularity. OECD and UNEP provide research frameworks and policy tools to support member countries in the transition. Part summary. The circular economy is not a novel concept. It draws from centuries of human practice and decades of environmental thinking. Its evolution from traditional resourcefulness to a globally recognized economic model reflects humanity's growing awareness of the need for sustainable growth. As countries, companies, and communities adopt circular strategies, they are participating in a historical transformation, one that reimagines the very foundations of our economy and relationship with the planet. Part 4: Linear versus Circular Models. Introduction. To understand the transformative nature of the circular economy, it's essential to compare it with the prevailing economic system, the linear economy. This part highlights the fundamental differences between linear and circular models in terms of design, resource use, waste management, and economic logic. It also explores the economic, environmental, and social consequences of each model. The linear economy model. The linear economy follows a straightforward, one-way production and consumption pattern. Take right-pointing arrow, make right-pointing arrow, use right-pointing arrow, dispose. This model is based on the assumption of infinite resources and unlimited capacity of the planet to absorb waste. It became dominant during the Industrial Revolution and has since fueled mass production and consumption. Key characteristics of the linear economy. Resource extraction from nature. Energy and material-intensive production. Short product life cycles. Planned obsolescence. Landfilling or incineration of waste. Impacts of the linear economy. While the linear model has driven industrial growth and technological advancement, it has also created systemic problems. Resource depletion. Critical raw materials are being consumed faster than they can be replenished. Waste generation. Billions of tons of waste, including plastic, e-waste, and food waste, are discarded annually. Environmental degradation. Linear systems contribute heavily to deforestation, biodiversity loss, water pollution, and climate change. Economic inefficiency. Products and materials lose value rapidly, creating losses in the form of unused potential and avoidable waste. These challenges signal that the linear economy is reaching its limits and is unsustainable in the long run. The circular economy model. In contrast, The circular economy is designed to keep materials and products in use for as long as possible, extracting maximum value before safely returning them to nature or the economy. Make right-pointing arrow, use right-pointing arrow, reuse, repair, right-pointing arrow, remanufacture, recycle, right-pointing arrow, make. Key characteristics of the circular economy. Resource efficiency, emphasis on reducing resource inputs through design and innovation. Value retention, focus on extending product life and recovering value from end-of-life goods. Waste minimization, materials are continuously cycled through biological or technical loops. Renewable inputs, preference for sustainable and biodegradable materials. Systemic design, products, processes and policies are designed to function in closed loops. Key differences: linear versus circular. The transition from linear to circular. Transitioning from a linear to a circular model requires a paradigm shift in how we design, produce, consume, and manage products and resources. Key enablers include policy and regulation. Governments can incentivize circular practices through taxes, subsidies, and standards. Innovation. Technological advancements in materials science, digital tracking, and product design are crucial. Consumer behavior. Public awareness and participation in recycling, repair, and sustainable consumption are essential. Business leadership. Companies need to adopt circular business models that prioritize long-term value creation over short-term gains. Hybrid models and the transition phase. In practice, economies do not switch overnight from linear to circular. Many operate in hybrid states, integrating circular practices such as recycling or eco-design into otherwise linear systems. Examples of hybrid models. Fast fashion brands offering recycling bins for old clothes, limited circularity. Electronics companies adopting modular design, but still relying on resource-intensive production. These transitional approaches are important stepping stones, but must evolve into fully circular systems for meaningful impact. Part summary. The linear economy, while historically effective for rapid industrialization, has led to significant environmental and economic challenges. The circular economy offers a restorative alternative that aims to retain value, eliminate waste, and regenerate natural systems. By comparing these two models, we can better understand the imperative and the opportunities for shifting toward a circular future. Part 5. Design for circularity. Introduction. Design lies at the heart of the circular economy. Most of a product's environmental impact is determined at the design stage. Decisions about materials, assembly, lifespan, and end-of-life handling all shape whether a product will contribute to a linear or circular system. Design for circularity is a philosophy and practice that reimagines products, systems, and services to enable circular flows of materials and minimize negative impacts. The role of design in a circular economy. Design in the linear economy has typically prioritized aesthetics, performance, and cost. In the circular economy, design priorities shift to durability, ensuring products last longer; modularity and upgradability, enabling parts to be replaced or updated; ease of repair and disassembly, allowing for maintenance and recovery of components; material safety and recyclability, selecting materials that are safe and easy to recover or biodegrade. Design decisions must consider the entire life cycle of a product, from raw material sourcing to manufacturing, use, and eventual return to the economy or environment. Design strategies for circularity. Several strategies guide circular design. A. Design for longevity. Create products with longer lifespans by using high-quality materials and robust construction. Reduce the frequency of replacements, thereby lowering resource consumption. B. Design for repair and maintenance. Ensure components are accessible and replaceable. Provide users with manuals, tools, or services for repair. Support local repair ecosystems to extend product use. C. Design for reuse and remanufacturing. Use standardized and modular parts that can be refurbished or reassembled into new products. Maintain design consistency to facilitate part reuse across different product lines. D. Design for recycling and material recovery. Use materials that are easy to identify, separate, and recycle. Avoid composites or hazardous substances that hinder recycling processes. Label materials to aid in proper sorting and processing. E. Design for biological cycles. Use biodegradable materials where appropriate, especially for single-use or short-life products. Ensure materials break down safely and return nutrients to natural systems, e.g., compostable packaging. Cradle-to-cradle design philosophy. The cradle-to-cradle C2C concept, developed by William McDonough and Michael Braungart, is a major influence on circular design. It envisions a world where products are designed as nutrients for either biological or technical cycles. Biological nutrients, safe compostable materials that enrich ecosystems. Technical nutrients, non-toxic materials that can be reused indefinitely in industrial systems. C2C shifts thinking from minimizing negative impacts to creating positive, regenerative effects through design. The importance of material selection. Materials determine a product's recyclability, carbon footprint, and impact on health and ecosystems. Circular design emphasizes renewable materials, e.g., bamboo, hemp, mycelium. Recycled content to reduce reliance on virgin resources. Non-toxic chemicals that are safe in both use and disposal phases. Material innovation plays a key role, with developments in bioplastics, smart textiles, and circular polymers enabling new design possibilities. Circular product examples. Fairphone, a modular smartphone designed for easy repair and upgrade. Patagonia offers clothing designed for durability and provides repair services. Interface Carpets uses modular tiles made from recycled materials with a take-back scheme for used products. IKEA, investing in recyclable materials and designing furniture for disassembly and reuse. These examples demonstrate how design can create new value propositions while supporting sustainability. Tools and frameworks for circular design. Designers and businesses use several tools to embed circularity. Life Cycle Assessment (LCA) measures environmental impacts across a product's life. Material Circularity Indicator (MCI) assesses how restorative a product or company's material flows are. Eco-design tools, software and guidelines to incorporate sustainability into design. Circular Design Guide, IDEO and Ellen MacArthur Foundation, a practical resource to apply circular principles in design thinking. Challenges in implementing circular design. While the benefits are clear, challenges remain. Technical complexity in disassembly and recycling of current products. Economic barriers related to redesign costs and perceived risks. Cultural resistance from consumers and industries accustomed to linear models. Lack of infrastructure for repair, remanufacturing, or recycling in many regions. Overcoming these requires collaboration between designers, manufacturers, policymakers, and consumers. Parts Summary. Design for circularity is a foundational element of the circular economy. It reshapes how products are created, used, and reintegrated into the economy or environment. Through strategic choices in materials, structure, and function, circular design enables waste elimination, value retention, and ecological regeneration. As industries evolve, embracing circular design is not just a sustainability imperative, it's a competitive advantage. Part 6. Business Models in the Circular Economy. Introduction. The transition to a circular economy requires not only rethinking products and processes, but also reimagining the way businesses create, deliver, and capture value. Circular business models provide the structural foundation for implementing circular strategies at scale, aligning profitability with sustainability. This part explores the various models that companies are adopting to thrive in a circular economy. Why business models matter. In a traditional linear economy, business models often rely on selling as many products as possible, as quickly as possible, with little regard for longevity, reuse, or post-consumption responsibility. Circular business models shift the focus from volume to value retention, from ownership to access, and from waste to resource regeneration. These models help extend product life and customer relationships, lower resource and production costs, improve brand loyalty and reputation, mitigate supply chain risks, achieve regulatory compliance and ESG goals. Types of circular business models. A. Product as a service (PaaS). Instead of selling a product outright, businesses provide it as a service. Example: Philips offers lighting as a service, retaining ownership of fixtures while customers pay for light usage. Xerox leases copiers and maintains them, charging customers per page. Benefits: incentivizes durable, repairable products, encourages resource efficiency and long-term customer engagement. B. Product life extension. Businesses generate revenue by repairing, upgrading, remanufacturing, or reselling used products. Example: Patagonia repairs and resells used clothing through its Worn Wear program. Caterpillar remanufactures heavy machinery components. Benefits: reduces raw material demand, creates secondary revenue streams, builds trust through after-sales services. C. Circular supply chains. Shifts to renewable, recyclable, or biodegradable inputs and builds systems to reclaim materials. Example: Interface uses recycled fishing nets in its carpet tiles. Lush Cosmetics offers packaging-free products and rewards customers for returning containers. Benefits: reduces environmental footprint, enhances material security and resilience. D. Sharing and platform models. Facilitates peer-to-peer sharing or company-led access to underutilized assets. Example: Airbnb and Zipcar allow users to share homes or cars, reducing the need for individual ownership. Tool libraries and equipment rental platforms provide access without acquisition. Benefits: increases asset utilization, reduces production demand and waste. E. Take-back and reverse logistics. Businesses design systems to take back used products for reuse, recycling, or safe disposal. Example: Dell and HP offer take-back programs for electronics. IKEA pilots furniture buy-back and resell schemes. Benefits: closes the loop on product life cycles, ensures responsible handling of end-of-life materials. Enablers of circular business models. For these models to succeed, several enablers must be in place. Digital technology, IoT, blockchain, and AI help track products, monitor use, and optimize maintenance. Policy support. Regulations, subsidies, and standards can incentivize circular innovation. Customer engagement. Educating users on circular benefits fosters demand and participation. Ecosystem collaboration. Partnerships across the value chain are essential for logistics, repair, and material recovery. Measuring business value in a circular economy. Traditional financial metrics alone do not capture the full value created by circular models. Businesses are adopting new metrics such as Material Circularity Indicator, MCI. Carbon footprint reduction. Product return and reuse rates. Customer lifetime value in service-based models. These indicators help assess environmental impact, economic resilience, and long-term viability. Challenges and barriers. Despite their promise, circular business models face several obstacles. High upfront investment in redesign and infrastructure. Cultural resistance to non-ownership models. Complex logistics for reverse supply chains. Legal and liability issues in product reuse and repair. Overcoming these barriers requires innovation, collaboration, and supportive policies. Emerging trends and innovations. Servitization of manufacturing is growing, especially in industrial sectors. Digital product passports are being introduced to track materials and enable easier repair and recycling. Startups and SMEs are emerging as leaders in circular innovation, often more agile than large corporations. Part summary. Circular business models are essential for turning sustainability into a viable economic strategy. By shifting focus from linear growth to regenerative value, these models empower companies to innovate, cut costs, build customer loyalty, and protect the environment. As more businesses adopt circular strategies, the economy as a whole becomes more resilient, inclusive, and sustainable. Part 7. Circular Economy and Innovation. Introduction. Innovation is the lifeblood of the circular economy. Transitioning from linear to circular systems requires not only changes in behavior and policy, but also technological, business model, material, and system-level innovations. These innovations drive efficiency, creativity, and new value creation across industries. In this part, we explore how innovation accelerates circularity, the emerging technologies making it possible, and the sectors leading the charge. Innovation as a catalyst for circularity. The circular economy thrives on rethinking and redesigning how we create and use resources. Innovation supports this shift by enabling new materials that are biodegradable, recyclable, or regenerative. New processes that minimize waste and emissions. New models of ownership and access. New systems for logistics, tracking, and reverse flows. Innovation transforms circular concepts from theory into scalable practice. Technological innovations driving circular economy. A. Advanced recycling technologies. Chemical recycling breaks down complex plastics into their original monomers for reuse. Enzymatic recycling uses biological processes to decompose materials. These methods go beyond traditional mechanical recycling and help manage hard-to-recycle waste streams. B. Additive manufacturing, 3D printing. Enables on-demand production with minimal material waste. Supports localized production and spare parts creation for repair and maintenance. Encourages modular design, simplifying remanufacturing. C. Artificial intelligence, AI, and machine learning. AI improves demand forecasting to prevent overproduction. Enables predictive maintenance in industrial machinery to extend product life. Supports material flow optimization and waste reduction in supply chains. D. Internet of Things, IoT. Tracks usage, wear, and location of products in real time. Enables product-as-a-service models through usage monitoring. Enhances reverse logistics by managing end-of-life collection and sorting. E. Blockchain and digital passports. Blockchain secures data on materials and components, ensuring traceability. Digital product passports offer detailed information on a product's origin, materials, and life cycle, empowering repair, reuse, and recycling. Material innovation. The choice of material is central to circularity. Innovations in materials science support sustainable design and waste elimination. Biomaterials made from renewable resources, e.g., algae-based plastics, mushroom leather. Self-healing materials extend product life by repairing microdamages. Smart materials respond to environmental stimuli, offering greater efficiency and functionality. These new materials open doors to circular solutions across industries, from fashion to construction. Business model innovation. Innovation is not limited to products or technologies, it also includes how value is delivered. Service-based models replace ownership with access, encouraging durability and reuse. Reverse logistics platforms help businesses manage returns, refurbishment, and recycling. B2B marketplaces for surplus or secondary materials, e.g., construction waste, packaging, reduce waste and open revenue streams. Sector-specific innovations. A. Fashion. Brands are investing in textile recycling, rental models, and closed-loop collections. Technologies like fiber identification and automated sorting support material recovery. B. Electronics. Modular smartphones, e.g., Fairphone, right-to-repair movements and take-back programs are growing. AI supports predictive repair and disassembly optimization. C. Construction. Use of prefabricated modular components reduces material waste. Reclaimed building materials are increasingly used in green architecture. D. Food systems. Innovations in food waste reduction, composting technologies and biodegradable packaging are rising. Platforms that connect food surplus with consumers, e.g., Too Good To Go, reduce edible food waste. Innovation ecosystems and collaboration. Circular innovation rarely occurs in isolation. It thrives in ecosystems that bring together startups, agile and disruptive, often leading breakthroughs in circular design and services. Corporations bring scale and supply chain influence. Governments provide enabling environments through funding, incentives, and regulation. Academia and NGOs conduct research, educate, and advocate for system change. Public-private partnerships and innovation hubs play a crucial role in supporting experimentation and scaling. Barriers to innovation in the circular economy. Despite momentum, several challenges hinder circular innovation. Regulatory uncertainty around waste definitions and product liability. Market resistance to new models, especially those requiring behavior change. Access to funding, especially for early-stage circular startups. Lack of infrastructure to support repair, reuse, and advanced recycling. Addressing these barriers requires systemic thinking, cross-sector collaboration, and long-term investment. Part summary. Innovation is a powerful driver of the circular economy. From cutting-edge recycling technologies to smart materials and new business models, circular innovation is transforming industries and redefining value creation. The path to a sustainable future depends on embracing innovation not just as a tool, but as a mindset, one that encourages regeneration, resilience, and radical rethinking of how we interact with the world. Part 8. Policy and Regulation for Circular Economy. Introduction. Policy and regulation are crucial levers in the transition to a circular economy. While businesses and consumers play key roles, governments create the frameworks and incentives that can either accelerate or hinder circular progress. Effective policies align economic systems with ecological boundaries by promoting resource efficiency, waste minimization, and product stewardship. This part examines how regulation is shaping the circular economy landscape globally. The role of government in circular transition. Governments can influence the circular economy through legislation, mandating standards, bans, or responsibilities. Economic instruments, taxes, subsidies, and incentives. Public procurement, using purchasing power to favor circular products. Information tools, labels, certifications, and awareness campaigns. Infrastructure development, supporting recycling, repair, and reverse logistics systems. The goal is to internalize environmental costs, encourage innovation, and shift behavior across sectors. Key policy instruments supporting circular economy. A. Extended Producer Responsibility (EPR) requires producers to take responsibility for the entire life cycle of their products, including take-back, recycling, or safe disposal. Examples: electronics take-back programs, packaging collection and recycling targets, deposit return systems for bottles and cans. Impact: shifts waste management costs from taxpayers to producers. Incentivizes better product design. B. Eco-design regulations mandate that products meet minimum requirements for energy efficiency, durability, reparability, and recyclability. EU example: the Eco-Design Directive sets standards for appliances like washing machines and refrigerators to be easier to repair and more energy efficient. C. Landfill and incineration taxes. Taxes or bans on sending materials to landfill or incineration encourage recycling and waste prevention. Example: Sweden and the Netherlands impose high landfill taxes to reduce waste disposal. D. Green public procurement (GPP). Governments prioritize purchasing goods and services that are resource efficient, repairable, recycled, or certified sustainable. Benefits: creates demand for circular products, signals market direction to industries. E. Material and waste bans. Outright bans on certain materials or products can remove problematic items from circulation. Examples: single-use plastic bans, prohibition on planned obsolescence in France. Global and regional policy frameworks. A. European Union. The EU is a global leader in circular policy with its Circular Economy Action Plan (CEAP) under the European Green Deal. Key initiatives include mandatory eco-design criteria, right to repair for electronics, mandatory recycled content in packaging, circular electronics and battery strategies. B. China. China's Circular Economy Promotion Law emphasizes industrial symbiosis, cleaner production, and resource efficiency. The country has also led in urban mining and recycling of electronics and metals. C. United States. While national circular policies are limited, states like California and Oregon lead with EPR laws for packaging and electronics, zero waste goals, repair legislation. D. Developing countries. Circular economy policy is emerging as part of sustainable development and poverty reduction strategies. Informal sectors are often key players in waste collection and material reuse. Challenges include limited infrastructure, need for capacity building, integrating informal workers into formal systems, enabling policy environments. To accelerate circularity, governments can create enabling environments through regulatory clarity and consistency, public-private partnerships, circular economy roadmaps, financial incentives like green bonds or innovation grants, education and workforce training. These policies must be coherent across sectors and aligned with climate, biodiversity, and industrial strategies. Policy challenges. Despite progress, several barriers remain. Fragmentation across jurisdictions and sectors. Slow legislative processes compared to the speed of innovation. Industry lobbying that delays or dilutes regulations. Global trade complexity in circular material flows. Measurement difficulties for circularity indicators. Overcoming these requires collaboration, stakeholder engagement, and systemic thinking. The future of circular policy. Looking ahead, circular economy policies are expected to integrate climate and resource agendas, linking circularity with net zero targets. Emphasize product passports and traceability for accountability. Foster urban circularity, addressing food, water, and material loops at the city level. Focus on equity and inclusion, ensuring fair transitions for workers and communities. International cooperation through platforms like the UNEP International Resource Panel, the Global Alliance on Circular Economy and Resource Efficiency, GACERE, and COP processes will be key in driving global circular alignment. Part Summary. Policy and regulation provide the backbone of the circular economy by creating the right incentives, setting the rules of the game, and guiding markets towards sustainability. From extended producer responsibility to eco-design and public procurement, governments play a vital role in accelerating the shift from linear to circular systems. For a truly circular world, smart, inclusive, and forward-looking policies are essential. Part 9: Circular Economy in Practice, Global Case Studies. Introduction. While theories and frameworks provide a foundation, the true potential of the circular economy is realized through real-world applications. Across the globe, businesses, cities, and communities are implementing circular strategies with measurable benefits for the environment, economy, and society. This part presents a range of case studies that showcase how circular principles are being applied in practice across different sectors and regions. Business case studies. A. Interface, USA Global Circular Flooring. Overview. Interface, a global flooring manufacturer, has embraced circularity through its Mission Zero and climate take-back programs. Circular strategies. Uses recycled materials including discarded fishing nets in its carpet tiles. Offers modular flooring systems that are easy to replace and recycle. Implements product take-back for end-of-life carpets. Impact. Reduced greenhouse gas emissions by 96% since the 1990s. Diverted millions of square meters of carpet from landfills. B. Philips Netherlands, Lighting as a Service. Overview. Philips pioneered the product as a service model with its pay-per-lux lighting service. Circular strategies. Retains ownership of lighting equipment while customers pay for light use. Designs products for repairability and upgradability. Reuses and refurbishes components. Impact. Increased resource efficiency. Strengthened long-term customer relationships. C. Patagonia USA Worn Wear Program. Overview. Outdoor clothing brand Patagonia promotes a culture of repair and reuse through its Worn Wear initiative. Circular strategies. Offers repairs, trade-ins, and resale of used gear. Designs for durability and recyclability. Encourages responsible consumption. Impact. Extended product lifespan. Save tons of clothing from landfills. D. IKEA, Sweden, Circular Product Pilots. Overview. IKEA is experimenting with circular approaches in retail and product design. Circular strategies. Offers buyback and resale services for used furniture. Pilots modular, repairable product designs. Uses renewable and recycled materials in products. Impact. Moves toward 100% circularity by 2030. Reduces dependence on virgin raw materials. Urban and municipal case studies. A. Amsterdam, Netherlands, Circular City Strategy. Overview. Amsterdam is one of the world's leading circular cities, with an ambitious circular economy roadmap. Key actions. Circular construction mandates for public buildings. Material passports for buildings to track resources. Support for circular startups and innovation hubs. Impact. Reduction in construction waste. Increased local employment in circular services. B. San Francisco, USA, Zero Waste Program. Overview. San Francisco aims to achieve zero waste to landfill. Key actions. Mandatory composting and recycling. Extended producer responsibility for electronics and packaging. Education campaigns and enforcement. Impact. Diverted over 80% of waste from landfill. Reduced environmental impact from urban waste streams. C. Ljubljana, Slovenia, Europe's greenest capital. Overview. Ljubljana became the first European capital to declare a zero-waste goal. Key actions. Advanced waste separation and collection systems. Public awareness and reuse centers. Circular procurement by local government. Impact. Highest recycling rate among EU capitals. Cost-effective waste management. Agricultural and food sector case studies. A. Too Good To Go Europe Food Waste Reduction App. Overview. A mobile app that connects consumers with restaurants and stores offering surplus food at reduced prices. Circular strategies. Reduces food waste by matching supply with demand. Encourages a cultural shift in food consumption. Impact. Saved millions of meals from being wasted. Expanded to over 15 countries. B. Loop Global Circular Packaging Platform. Overview. Loop partners with major brands to deliver products in durable, reusable containers. Circular strategies. Consumers receive and return products in refillable packaging. Containers are cleaned, refilled and reused. Impact. Reduces single-use packaging waste. Promotes system-wide design for reuse. Social enterprise and community case studies. A. Green Collect Australia Office Waste Solutions. Overview. A Melbourne-based social enterprise that recycles and repurposes used office items. Circular strategies. Diverts office waste from landfill. Employs marginalized people for sorting and repurposing. Impact. Created inclusive jobs. Recovered tons of materials annually. B. Chintan, India, empowering informal waste pickers. Overview. An NGO that supports informal waste workers and promotes circular waste management. Circular strategies. Integrates informal waste pickers into formal systems. Advocates for inclusive waste policies. Impact. Improved livelihoods for thousands of workers. Increased recycling rates in Indian cities. Lessons learned from practice. From these cases, several key insights emerge. Design for circularity is fundamental. Partnerships and collaboration are crucial, across supply chains, sectors and communities. Digital tools and data enable traceability, optimization and transparency. Consumer engagement and education foster cultural shifts. Policy alignment supports scaling and integration. Part summary. The circular economy is no longer a theoretical ideal. It's being implemented around the world through innovative business models, policies, technologies, and community initiatives. These case studies demonstrate that circularity is viable, scalable, and impactful, offering pathways to sustainability that also deliver economic and social value. The challenge ahead lies in scaling these successes and adapting them to local contexts. Part 10. The Future of the Circular Economy. Introduction. The circular economy is no longer a niche concept. It is emerging as a central pillar of sustainable development. As climate change, resource scarcity, and biodiversity loss intensify, the transition to a regenerative and restorative economic model becomes more urgent. This final part explores the evolving landscape of the circular economy, highlighting future trends, opportunities, challenges, and the roadmap for a truly circular future. Evolving drivers of circularity. The future of the circular economy is being shaped by a convergence of global forces. Climate action. Circular strategies reduce emissions through energy efficiency, reduce material extraction, and carbon sequestration. Technological advancement. Digital tools, AI, blockchain, IoT enable better tracking, optimization, and value recovery. Consumer awareness. Shifts in values towards sustainability, minimalism, and ethical consumption are gaining momentum. Resource scarcity. Rising costs and scarcity of virgin materials make circular sourcing more attractive and necessary. Policy pressures. Governments are increasingly mandating circular approaches through legislation, targets, and incentives. Future trends in circular economy. A. Digital circular economy. The integration of digital technology with circular strategies will unlock new efficiencies and business models. Digital product passports for traceability and material recovery. AI-driven design and production for minimal waste. Smart logistics to optimize reverse supply chains. B. Circular bioeconomy. The bioeconomy will evolve to include more circular approaches, leveraging natural systems and renewable biological resources. Use of biomass and bio-based materials. Compostable packaging and regenerative agriculture. Valorization of organic waste into energy or new products. C. Localized circular systems. Urban and regional systems will become more self-sufficient and circular, reducing reliance on long global supply chains. Urban mining of materials from buildings and electronics. Localized food systems with composting and vertical farming. Circular city planning that integrates water, waste, and energy loops. D. Just and inclusive circular transition. The future circular economy must address social equity and ensure that the benefits are widely shared. Reskilling and education for circular jobs. Inclusion of informal workers and vulnerable communities. Focus on gender equality, diversity, and access in circular systems. 10.4 Circular finance and investment. To scale the circular economy, significant financial flows must be redirected from linear to circular models. Rise of green and circular investment funds. Integration of ESG, environmental social governance metrics. Blended finance mechanisms for de-risking innovation. Impact investing to support circular startups and infrastructure. Circular finance will play a critical role in accelerating innovation and adoption. 10.5 Challenges to overcome. While the potential is vast, several systemic challenges must be addressed. Scalability. Many circular initiatives remain localized or pilot stage. Policy fragmentation. Lack of global standards hinders trade and scalability. Behavioral inertia. Consumers and businesses often resist change. Linear lock-ins. Existing infrastructure, business models, and regulations favor linear systems. Measurement gaps. Difficulty in tracking circular performance and impacts. Solving these challenges requires coordinated efforts across governments, businesses, academia, and civil society. The role of education and culture. Building a truly circular future will require a cultural transformation. Integration of circular economy into education curricula. Public campaigns to shift mindsets towards sufficiency, sharing, and stewardship. Empowering the next generation of circular designers, entrepreneurs, and leaders. Changing how we think, teach, and live is key to mainstreaming circularity. A vision for 2050. Imagine a world in 2050 where Waste is virtually eliminated. Products are reused, repaired, or regenerated. Cities are designed as ecosystems, cycling materials and resources locally. Business models are service-oriented, not product-centered. Natural systems are restored, not exploited. Value is defined not just in financial terms, but in environmental and social well-being. This is the promise of a circular future, not just a new economy, but a new way of being on the planet. Part summary. The circular economy is not a distant vision, it is a practical, scalable, and inclusive path forward. As technology, policy, culture, and finance evolve, the momentum behind circularity will only grow. But success requires systems thinking, collective will, and long-term commitment. The future is not predetermined, it is created. And with circular principles at the core, we have the tools to build a resilient, regenerative, and just world for all.